Hi everyone, welcome to my talk about Flexible Multi-Tenancy with vCluster. My name is Piotr Zaniewski and I work at vCluster Labs. If you haven't heard about us, you can think of us as a company that likes Kubernetes so much that we put Kubernetes inside of Kubernetes. So we did that, and this enables all kinds of crazy scenarios. So today we are going to talk about multi-tenancy. As SREs, we deal with this problem all the time. Having multiple teams means simply we have to provide various resources and slice and dice our clusters in various ways. So this is courtesy of ChatGPT showing us how regular tenancy works in Kubernetes. So you have a noisy neighbors problem. Your neighbors plays guitar at 12 p.m. People are walking around. So in Kubernetes, it's the same, right? You have pods that can steal your resources, and that's usually not a big deal if you have clusters dedicated for dev or test, but that can be a problem. So how vCluster does it, it creates this. So it looks ridiculous. You can have a house inside of the apartment, but that's really what vCluster is. Essentially, you can have Kubernetes control plane running inside of a pod inside of Kubernetes. And this, of course, unlocks all kinds of scenarios. So this means that every team can have their own dedicated, fully fledged Kubernetes compliant distribution and do whatever they want with it with admin rights if you decide to give them so. Here's even crazier image. So this idea supposedly represents the fact that we have a lot of underlying services in our clusters. Some of the virtual clusters we will create would want to consume those services. Some of them we want to isolate. So this is a messy world of multi-tenancy. There is no one size fits all. We might have tenants that are external to our infrastructure. We might want to isolate them significantly more. We might have internal tenants that we are happy to share our internal services with. So how virtual cluster works? Forget the houses, we are back in Kubernetes. So the idea of virtual cluster is that each of those boxes represents a single Kubernetes pod. In this pod, we have not only Kubernetes control plane, so kubeAPI, scheduler, controller manager, but we also have something which is called syncer. What vCluster does, it synchronizes your resources between virtual cluster and host cluster. And again, this opens up quite a few interesting use cases. So here we can see Team 1 runs all the workloads like Nginx, maybe web apps, maybe cron jobs, whatever they want to run there. And they share underlying services from host cluster. Your typical cert managers, egress controllers, and stuff like that. However, Team 2 have their own services. So we deploy the cert manager and egress controller inside of the virtual clusters. So this flexibility is really important, and it opens up quite a lot of use cases. So now we are swapping to a demo part. This will be an interactive demo with sites. What I have done here, I have already deployed a kind cluster on my computer, and we are going to explore how virtual cluster can fulfill this initial promise of flexible multi-tenancy. So this is ready, and just to iterate one more time on the same idea, if we have shared services, we want to, at one end, maybe completely isolate them. So for like dev environments, maybe this is a complete zero trust. We don't want to share those services at all. For our internal teams, we want to share some of them. And maybe for external, we would like to not share those services at all. So we will do just that. So first of all, let's check what nodes we have. So here we have my kind cluster running 2 nodes, work on node and control plane node. Nothing exciting here, just a regular kind cluster. Everybody knows what kind cluster is? Everybody use it? Yeah, that's a Swiss Army knife tool for all the demos. So what we're going to do first, we're going to apply Nginx controller just to get something going inside of our cluster. Nothing crazy again, just applying the manifest remotely and applying it to my kind cluster. So far, let's see how it looks in actual K9s. You can see containers are being created. Everybody uses K9s? K9s is awesome. It's a completely free plug for K9s. It's an open source tool. If you don't use it, it's a really nice tool to interact with your cluster. So those things are happening. Containers are being created. So this is good. Let's go one step forward here. So I need to zoom it out a little bit. Let me know if it's still okay, not too small. What is a challenge with multi-tenancy in general? So when we think of namespaces, this is the first isolation model that we all know. If you work with Kubernetes and you want to give something to developers, then this is going to be typically namespace. You're going to give them namespace team A, namespace team B, and so on. This is all good and fits certain use cases, but creates specific problems. So first of all, there is limited isolation between tenants. Kubernetes doesn't provide strong guarantees for the workloads not to cross namespace boundaries. You can, of course, and should have things like network policies, but just with namespaces, it's really difficult. And one important problem that namespaces create is that there is no CRD isolation. So CRD, as you might know, custom resource definition in Kubernetes is a global resource. So it's installed globally and it cannot have a namespace scope. And of course, a subtle problem that this creates is that if you have shared services, then you're locked into their versions. There's no way for team A to have a different version of Istio service mesh, for example. Okay, let's zoom in. So how vCluster addresses this, a little bit bigger. So for development scenarios, you have dev test environments that you can create, whether this is in development, maybe in CI. And then again, people have full admin access. You can give them kubectl access. They can do whatever they want there. They can destroy the cluster, install anything. Of course, you can control it. There's a very high degree of control you can have and tell what are teams capable of doing on vCluster and what not. So production, of course, you can use it in production. vCluster has a quite interesting scale of multi-tenancy. I'm going to show you this table. You have to memorize this table. No, I'm joking. It's a lot of colors, can be confusing. This is quite interesting document. I'll share a link with you if you're interested. And this kind of goes through the whole spectrum of multi-tenancy and what you typically have. So you start with namespaces, and vCluster supports all those various modes of multi-tenancy that we just talked about. This exists, and it's worth reading. All right. You can apply vClusters in all kinds of ways. So you can give them to your data science team, and you can configure them such that they will be more useful or they will be more geared towards running inference, let's say, on AI. You can install a different scheduler. You can swap, for example, regular scheduler with Kai scheduler from NVIDIA. So all those things are possible within vCluster. That's why it solves the whole plethora of problems. And my favorite partners, in my case at least, I often interact with the external vendors, and I have to give them access to my resources one way or the other. And vCluster helps here a lot because I can control on a very high fidelity what vendors can see, what they cannot see, and what kind of interactions are permitted from my perspective there. All right, so back to creating our first virtual cluster. So how do we go about it? It's actually super easy. So we have a file called dev values. Let me swap real quick to it. But I can even type. So super simple YAML, right? We define certain configuration parameters here, things like policies in this case, limit ranges, and sync. And I'll talk about sync a little bit more. But if you're interested, you can find all this YAML right in the docs here with explanations about every single configuration point that vCluster exposes, and there's quite a lot of those. But for our purposes, this is just a simple YAML. So what does sync does? This is important concept in vCluster synchronizes resources between your virtual cluster and the host cluster. And let's see how this happens. So first of all, let's get it running. This will take a moment to create it. So what we are doing now, we are creating a new virtual cluster based off of the values that you've seen earlier. So let's use our favorite Kubernetes viewer to see what's happening here. You can see at the very bottom, there is a new pod. As I promised, vCluster is just a single pod. Who can tell me why this is named dev minus team minus 0. Any Kubernetes specialist here? Why there's a 0? Yes, I have no reward, but that's exactly what it is. So vCluster uses by default stateful set because we have to initialize it in a specific order, and you obviously can also configure vCluster in HA mode, high availability mode, where vCluster will act as a little bit more resilient. So let's see what is happening. This is a conference Wi-Fi, so this will take a moment for us to pull this Kubernetes image. But what it's doing behind the scenes, it's pulling the Kubernetes image. There you go. Now it worked. And it will initialize itself soon. And inside of this pod, we will have all the regular Kubernetes stuff. So let's go back to presentation. So this is what we did. We created a virtual cluster inside of a pod. And I promised you that this is a regular Kubernetes cluster. So let's see. vCluster CLI gives us an easy option to connect to it. So when I initiate this command, it will essentially, under the hood, swap my kubeconfig from my kind cluster to virtual cluster. So this is one thing that is typically a bit crazy to think about, but if I swap again, and this needs to initialize, so we will still need to wait a little bit for it to initialize. Demo gods are not with us here, so we need to give it a moment. So this command is still running. vCluster needs a little bit more time to initialize due to Wi-Fi. I should have predicted it, but it should soon be done. So let's talk a little bit more about what vCluster is in general. So all the components that you will see, once it initializes, vCluster essentially takes the Kubernetes binaries bundle, which is API server, controller manager, scheduler, initializes it by copying it into its pod, and additionally it has this famous syncer component which runs as a container in vCluster and takes care of synchronizing resources back and forth between virtual cluster and host cluster. Okay, finally this is done, so now I can swap here again and show you that now, if you see at the top here, the context is different. We are not anymore connected to our kind cluster, we are connected to the pod running inside of a kind cluster, and as you can see, this just runs core DNS by default. There's nothing here, it's just an empty Kubernetes cluster that runs inside of our kind cluster. So now let's see this. So as I mentioned, init container grabs all the Kubernetes binaries. By the way, those binaries are versioned independently, meaning each virtual cluster can run different Kubernetes versions. So you might have Kubernetes 1.32 on your host cluster, and each virtual cluster can run different versions. There's up to 3 version difference that you can support. All right, so where's the data? I always ask this question. So this is super simple. In virtual cluster open source, the data lives in SQLite. So inside of our pod, we have another volume where we store the data, and that's how it works. This is, of course, just initial open source experience. You can provide external backends to vCluster. This is very easy. You can configure Aurora, you can configure Postgres, you can configure external etcd cluster. This is just what you start with, and we have this data here. All right, so since this is a regular cluster, it should work as one, right? So let's apply a simple web app. This is just a web app, and here I outputted the requests, because remember, initially we created this cluster with certain constraints as far as resources go. So we have created this web app inside of our virtual cluster, and if you can swap here, you can see that we have this web app pod ready in it. Okay, cool. So if this works, and let's hope it does, I should be able to curl this page. Moment of truth. Port forwarding. There you go. Works. So we are serving a web page from inside of virtual cluster that is inside of the actual host cluster. So this is the picture where we had the house with small houses inside of it. So each of those small houses represented actual Kubernetes, and this page is here, so we can actually see it in all its glory, also accessible here. Host 8081, I think it was, yeah. There you go. Kubernetes demo with aggressive green color. Okay, So this worked, but now, what if you want to take your virtual cluster and say, okay, I get a bunch of stuff here. I have my web pages, I have my jobs, I have my configurations. I want to recreate all of it. I want to treat it like a VM image. No problem. You can take a snapshot. So vCluster snapshot does this. If anyone has a laptop out and you want to try, you can quickly install vCluster or after this talk, and you can restore our vCluster with the super awesome web app from this OCI URL. Anybody knows the service TTL-SH? Another plug for free. If you ever need to share a Docker image or any OCI compliant artifact, and you don't mind it being publicly accessible, this is a really cool way to do it. You don't need a login, you don't need the Docker credentials, you just use this TTL-SH service, and you simply do this like here. So let's execute this. So now we are playing around with tenancy a little bit differently. We are saying we might have a tenant that needs this vCluster to work on a different host cluster. Let's imagine that we are moving from EKS to AKS. I don't know what anybody would do it, but we decided to do it. And we take our vCluster that says we have a lot of web apps, a lot of stuff deployed there, and we want to make sure that all of its state is moved as if it were a VM image. That's how I like to think about it. So again, if you want to snap a photo of this page or remember this URL, for an hour from now, it will be available, and you can restore it with a restore command. I'll show you this command in a second. So let's create another kind cluster. So now it's getting real. We have two kind clusters. We're going to have soon lots of vClusters, and this is obviously mimicking real world to an extent. You never deal with one host cluster as SRE. We usually deal with a lot of those, most of them EKS, and they are just sprawled all across the company. I'm trying to simulate the same concept of having multiple host clusters as well. And now, if everything goes okay, we can actually restore. You can see we create a virtual cluster with a restore flag, and we are grabbing this OCI compliant artifact from the TTL-SH. And it should be there for an hour longer, so if anybody wants to try it. Of course, I didn't take into account the conference Wi-Fi, so this will probably take a little bit. But what it will do, hopefully soon, it will restore everything, including the current state, which is really cool. I use this feature in my day job all the time because we are moving a lot of vClusters around, and this is quite handy. So let us see what's happening here. So if I swap now, you can see that we have kind host 2. Remember, we created a second host cluster. And oh, this one actually was faster. So now vCluster created this snapshot. And from the snapshot, it will trigger creation of vCluster. And it will pull all the state from etcd. In this case, not from etcd, but from SQLite, but from its data store. So now it's creating the same vCluster as we had earlier. And I hope this will be faster because we have the Kubernetes image already available. But let's see. Oh, it's still pulling it. All right. So this will restore it. And we're going to wait a second. And if this works, we should have exactly the same experience with our web app, right? So our vCluster now is being restored from one infrastructure to the other. We do this from one kind cluster to the other, but obviously in real case scenario, it would be between managed Kubernetes clusters or bare metal clusters. It doesn't really matter, vCluster runs everywhere. All right, this is clearly lessons learned for later. Don't pull images on conference Wi-Fi. So we're gonna skip this step for now. Let's just delete this. You have to trust me that this is going to work, and we would have our web app definitely there. I have deleted the kind cluster now. And now we are going to create another vCluster. This one is slightly different. This is for prod use cases. And let me first cut this prod values. So cut prod values. Here you can see we have a core DNS enabled, and we are synchronizing all the services and ingresses. So if we actually run something in vCluster, we have various ways of telling vCluster, take all my ingresses, in this case, for instance, and synchronize them from the host cluster, which is in our case kind. And it says, okay, I'm going to grab all your ingresses so that you don't have to install ingress controller on your virtual cluster. I'm just going to synchronize the CRDs and synchronize all the resources. Same with services. If you have any services that are going to be on virtual cluster, I will automatically synchronize them down. Those are like minutiae of how Synchro works, but it shows the power of virtual cluster, how we are actually utilizing the dance between host cluster and the virtual cluster by being able to be very flexible with synchronizing and deciding what we want to do. So now let's connect to this prod team. And this should be super fast right now. Yeah, good. And if this works well, we should actually be able to apply our web app and actually resolve it on our internal DNS. This is, again, just showcases one of the use cases, right? Otherwise, we would have to like do port forwarding and other things, but we didn't have to do this because we have DNS available. So another advanced configuration. So let's disconnect from this vCluster. And we are going to now use one of my other favorite features, which is seeding vCluster, what was it? Partner values. So you can see here that we are creating the virtual cluster with pre-populated values. And this is something that we all do very often. So I like to think about this as a Kubernetes cloud init. So we really want to make sure that the vCluster we create already has config maps. Maybe secrets is a bad idea unless I have an external secrets operator somehow. But it can have pods, it can have anything that we decide to configure and pre-populate the vCluster with this deployment. There are other ways of doing it, not just in line like this, but this is showing it quite nicely. So we have already disconnected it, and now we're going to apply this partner team. Okay, so this will work. And the partner team, you will see that once the vCluster comes up, and everything is hopefully okay, you will see that all those config maps and secrets will be populated in the virtual cluster as well. And there they are. We have here our platform config, and we have here platform credentials secret available on the virtual cluster because we decided to populate it with it. So let's sum it up what vCluster does and what it helps us with. So we've seen essentially three separate use cases. We have a dev team that can run pods with quotas, can only interact with cluster IP services from the host cluster, does not have ingress shared, cannot see actual nodes, it can only see pseudonodes, and have their own config maps and their own enforced resource limits. And likewise, prod team and partner team have different tenancy boundaries. So I like to think of this as having multiple sliders where I can move and decide whether something is zero trust or I trust it more, whether something needs their own services or I'm happy to provide my own shared services. And this also goes further than that. Recently, we have released things called private nodes, vCluster standalone, which essentially enables you to move this isolation even further. All right, so let's list those vClusters. It's very easy to list them. So we have 3 of them running. This is the version of vCluster, and since when they are available, as admins, we can, of course, see it like this. But doing it like that is a little bit painful, so we can do, let me show you something real quick. So this is right cluster. Oh, I'm mistyping something here. All right, so now you will see my email address. Feel free to write me something about vCluster. So what I'm doing now, what I'm showing you, is since we've listed all those vClusters, and you wouldn't have 3, if you are really serving a lot of teams and tenants, you would typically have quite a lot of those, right? So we have people that have thousands of virtual clusters. There are also customers, to be fair, that have thousands of actual clusters. So the cost saving here is pretty clear. So what I'm doing now, I am deploying our management solution, which is consisting of a web UI and an operator that enables us to manage virtual clusters in a very easy way. Since I have 2 more minutes left, I just wanted to show you this before we move to the questions. This will, as we all know, on this Wi-Fi take a little longer, so apologies for that. But as it's doing, we can go back here and just recap how vCluster solves various use cases. So we've seen dev test environments. We can provision virtual clusters extremely quickly. vCluster itself comes up in seconds, if you pull all the images, of course. Tenant isolation, we talked extensively about how tenant isolation works. Independent versioning, this is really important for me, and I think for all SREs, because people don't really think about it. I have whatever version of Nginx ingress controller, but we think about it deeply. And vCluster enables this, that one team can have this version, another team different version. This applies also to Kubernetes. There are reasons why our data science team cannot migrate to new version of Kubernetes, and we can keep them on an older one for a while with vCluster, while advancing other teams with an upgrade schedule. And the security boundaries, this is like the core component. Like everything here, we can say, is it zero trust, is it not zero trust, and you can move the slider back and forth. All right, so that's all for the talk itself, but let's see if our cluster, oh, it's still running. So I don't think we have enough time to show you how it looks, but you can visit our webpage or the docs, and you will see like a really nice web UI with how you can manage virtual clusters at scale. So I think we are right on time, so I'd be happy to take any questions.
2 questions, actually. So the first one should be easier to answer. You mentioned that you can have different versions of Kubernetes running in vCluster compared to the host cluster. How does this affect the syncing if the CR versions are incompatible between Kubernetes versions? I guess it just won't work.
So the only thing that you really care about is pod version, because the only real thing that is running on the host cluster is that vCluster synchronizes the pod down to the host cluster, but everything else is just an entry in the data store. So you can have completely different versions, and you can have like completely, if you talk about CRDs, you say we have a CRD that is installed on vCluster, so Istio, let's say, installed on vCluster, those CRDs are completely separate from the CRDs on the host cluster.
But if I want to sync them, they should be compatible, right? Because otherwise I couldn't sync them to the host cluster.
If you want to sync them, absolutely, yes. So if you really have a scenario where you want to share the services, then you wouldn't install them. So vCluster wouldn't have those by default. They would just be synced up from the host cluster. So you wouldn't have a version problem there either.
Yeah. The second question is more around nodes. Since you mentioned you have this real node sharing in the production example, how does workload scheduling across nodes work from a virtual cluster? Since you mentioned the virtual cluster is contained to a single pod. Like how do I schedule on other nodes in this case?
Absolutely. So I think this is a little helpful here. Not this horrible table, but the general idea. So let's hope that this has some kind of, this picture, I was missing it. Okay, so here, the way it works, you start with shared nodes. The first vCluster starts with shared nodes. I'm not sure what, go away. So shared nodes, there's no, everything schedules whatever it wants. Another quite interesting one is dedicated nodes, meaning that you have an option to label, it contains some tolerations to label vClusters themselves so that they can schedule only on the nodes with those labels. So that's using labels. You can also have completely dedicated nodes for tenants, so literally separate node pools. We call this private nodes. And in between, you can also have something which we called virtual nodes. This uses a standalone product called vNode. And what it does, it essentially uses a shim over runC that inside each node creates like a virtual node pool. So there's various use cases and kind of ways how you can schedule it, up to a point where you have completely dedicated nodes, like physically isolated nodes. And we are also working on an exciting feature where you can have those nodes spanning across distributed networks. So you can have one node from your home lab server, one node running on your toaster, whatever, everything could work.
Okay, one more.
The question I have is, I think it's a really great approach especially for the development time and things like that. But I have a question around how much is that going to affect then the cost or the underlying cost then of the whole clusters itself that you're adding these virtual clusters to? Is there a potential then to have an explosion of resource cost in the whole cluster?
So this is actually, it's a good question. So we think about it as reverse. So if you have multiple host clusters, so you deal with 10 EKS clusters, 100, right? Then you already pay like extremely high cost for the EKS itself. So when we work with our customers, we often go through this exercise of converting certain host clusters into virtual cluster, because virtual cluster is a pod, so it's 200 megabytes or something, right, running on your host cluster. So suddenly you eliminate the whole class of costs that is connected to having multiple host clusters, right? So you can come from 10 EKS clusters maybe to 3, and you convert certain, let's say if team A has dedicated EKS cluster, you convert them to using vCluster itself, and this is significantly cheaper. The cost of the pod is just a pod, right? So the cost is, if you want to run additional pod, this will be like 200, 300, don't remember exactly the memory footprint there of a pod, but that's it. That's just a pod. So there's no inherent additional cost for it. Yeah. Really good question.
All right. Yeah, I think it's time for the break. So more questions around the coffee. We take a 30 minutes break for the coffee and then resume in all 3 screens with separate tracks. Thank you.
Thank you, guys. Thank you.